Organic chemistry. When we hear the word organic, it means natural. Because in the history of organic chemistry, the first few organic compounds that were discovered usually exist in living organisms. So when we talk about organic chemistry now, it doesn't just revolve around the compounds that are present in living organisms, but rather it can also be seen as a synthetic compound. Now, in this video, we're going to learn about what organic chemistry is and what are the common general characteristics of our organic compounds. So, organic chemistry really study the compounds that contain carbon, usually hydrocarbons, the one with hydrogen paired with carbon. And carbon is the primary star of organic chemistry. It all begins with carbon. So it's important that we have to understand the chemical properties of carbon. Also, why is it able to form? Around 10 million compounds have been identified in organic chemistry, in organic compounds category, and about 1,000 new ones are identified each day. So, carbon, the three things that we have to know and recall about carbon is that it has the capability to form single, double, and triple bonds. It also has an intermediate electronegativity value, which means that it does not lose electrons nor gain electrons, but rather it shares its electrons. That's why the common chemical bond that you see in organic compounds is a covalent chemical bond. And this carbon forms strong bonds with carbon, hydrogen, carbon forms strong bonds with hydrogen, oxygen, nitrogen, and some few metals. But usually it's these three nonmetals, H, O, and N, that carbon pairs itself to. And then, so organic chemistry, it studies about carbon containing compounds, particularly hydrocarbons, and the derivatives of these hydrocarbons, which we will learn in the next sets of videos about what are these derivatives, and we will understand each of them. In organic compounds, what are these? We said it's carbon containing, but there are a few exceptions to carbon containing compounds that do not belong to the organic compound family. The ones the ones that is carbonate, bicarbonates, carbides, and just carbon itself, and then such as the compounds carbon monoxide, carbon dioxide, sodium carbonate, sodium bicarbonate, and calcium carbide. These five compounds are considered to be part of inorganic compounds. These compounds, the bonding processes that involve around them doesn't qualify to the characteristics of your organic compound. So there's just really a few of them that are exceptions to the organic compound family. So, what are the general characteristics of our organic compounds? Organic compounds are covalent in nature. We said that that carbon shares its four valence electrons to the rest of the other nonmetals. Therefore, organic compounds are covalent, have covalent bonds, and usually they are nonpolar in nature. Because covalent bonds are less strong compared to ionic bonds, that will lead to a lower melting point and boiling point for covalent compounds or the organic compounds for this. So all organic compounds have lower melting points and boiling points compared to our inorganic compounds. Thermal instability. Many organic compounds are thermally unstable because they get burned or they decompose into simpler molecules. Because they're covalent in nature, that means that their covalent bond can as easily get destroyed, especially if you subject them to extreme heat. Fourth, their molecular mass are usually big because hydrocarbons and their derivatives can form very long chains of hydrocarbons. And when they form long chains, big molecules form, and so you expect them to be heavier. Fifth is inflammability. Most of the organic compounds are inflammable and burns exothermically. That means they release energy when they burn in a sufficient supply of air which is primarily oxygen gas, to yield carbon dioxide, water, and heat energy. Then sixth, they burn with smoky flame. So most organic materials give smoky flame upon burning. Sometimes, usually it's black smoke. That's an indication of carbon. Isomerism. Organic compounds have large number of compounds that have the same molecular formula, take note, but different structural formula. This phenomena is known as isomerism, and the compounds are called isomers. The analogy for this is it's like twins. Two compounds may share the same chemical formula, but their structural formula differs. When we say structural formula, it's the way the atoms bond and arrange in the molecule. So, stay tuned to the next video about isomerism. This will be discussed in detail. Number eight, reactivity. Most organic compounds really react very slow and they require specific conditions for their completion. Specific conditions may be in a form of the participation of an enzyme or catalyst so as to speed up the natural slow reaction process of organic compounds. Ninth is solubility. Most organic compounds, we said, because they're covalent in nature, they're largely non-polar. So they are insoluble in water because water is polar. But you know that like dissolves like. So if organic compounds are nonpolar, it dissolves in organic solvents that are also nonpolar like benzene and ether. So while some organic compounds are polar in nature, such as alcohol, because of the presence of oxygen, oxygen will cause the unequal distribution of the electrons, which will lead to the polarity of your molecule. And so that makes alcohol to be soluble in water. But majority of your organic compounds are insoluble in water. And lastly, conductivity. Organic compounds really do not conduct electricity. Now, the fact that they're nonpolar and there's no unequal distribution of the electrons, and there are no ions present in organic compounds when you dissolve them. For those that are soluble in water, um, they may split, but it's very, very few or zero at all. So they don't have ions. Conductivity is very, very poor. Okay, so that's it. That's about carbon. And please know our carbon, the main star of organic chemistry, has an atomic number of 6 and it has the mass number of 12.0107 or the molar mass number, and it's capital letter C. And it loves so much hydrogen such that the common compounds in organic chemistry are hydrocarbons. So that's it for now. Stay tuned for the next video on what are the different types of bonds and how we draw structural formulas of organic compounds. This is it. This is Madam Narca saying do not give up, never stop learning, relearning, and unlearning. Bye for now. God bless you.